Hello everyone. We are starting the session now. Over to you, Nishad. So do you start? Yes. Like most of the person have joined. So in the meantime, like other people will join in the meantime.
So, hello everyone. I Nishat Ilyas from ISI India. Today I will be presenting a webinar on the battery pack design. So, I welcome everyone here in the virtual seminar. So, going ahead with the presentations, I will be explaining what a battery pack is, how to design a battery pack, what are the various criteria we have to take into the consideration for designing a battery pack, and after all, designing a battery pack, what are the various parameters on which we have to define or which have to evaluate the performance as well. So moving ahead, of the things which I will be going to cover in this webinar is what a battery pack is, its basic requirements, and the unit of the battery pack, that is the cell, its construction, its working mechanism, the parameters on which the performance of the cell is evaluated, a pack design, and parameters for the designing the pack, and how to design a battery pack, and lastly the some of the basic studies of the market of the electric vehicle producers. First of all, we see what a battery pack is. In our daily life, we see running vehicles on CNG or on the petrol or on the gasoline. We rarely, or nowadays, we there is, with increasing number, we see the moving electric vehicles. So same like the combustion engine, where the petrol, gasoline is burned, and the heat is changed into the mechanical energy. Same like that, in case of the electric vehicle, the chemical energy is first converted into the chemical energy is first converted into the electrical energy, and then it's converted into the mechanical energy. So as same like as the combustion engine, the petroleum is the source of the energy. Same like that, in case of the electric vehicle, the battery pack is the source of the energy. It is the core of the electric vehicle technology. And when the cells are configured to the series and the parallel, and it makes the core of the battery pack. And when installed with the BMS, it's control all the systems and all the inputs and output of the battery pack, and maintain the power level within the design developed, or as per our requirement for which we will be using our battery pack. As I have told, the cell, which is the basic or the primary constituents of the battery pack. So we will look into it, that how actually a cell works, what are the different parts of the cells are, and the mechanism inside the cell. So basically there are three parts in the cell, that is the cathode, anode, and the electrolyte. So there are three basic parts of the cell, that is the cathode, anode, and the electrolyte. The cathode is the positive terminal, while the anode is the negative terminal of the battery, of the cell. So we will now see that what happens when we put the cell into the charge, and what will happen when we put the cell on the load, or put a load on the cell. So when there is a external potential applied on the cell, or we apply something like biasing, we apply the potential on the cell, then there a reaction starts inside the cell, and there are two things, like what happens to the outer of the cell and what happens inside the cell. The electrons, the charges, move from the cathode side of the, that is the cathode side of the anode, and the lithium ions, which are inside the cell in their oxide form, a reduction starts here, and they go to this graphene. That is here the material used, that is the graphite, which is a layered structure of the graphene. That is, when we go to the atomic level of the graphite, that you will find the 2D structure, that is the graphene. And graphite is the layered structure of the graphene. So this trapped in this, or sometimes it get intercalated between the sheets. So, and when there is a, and the what happens in the, at the outer of the cell, that is electrons move from here to the, that is the, this anode side of the, this anode side of the cell. And when we put the load on the cell or on, so in that case there is a reduction starts on the anode, oxidation starts at the cathode, and these intercalated lithium ions again start coming back to the, this side of the, they starts coming back to the, this side of the cell, that is the cathode or the positive side of the cell. This is how and the charges again they start going back to the, this side of the cell, that is the from anode to the cathode. This is how lithium cell works while on charging and discharging.
Sir, can you explain the, sir, interrupting you for a minute, sir, can you explain this working the whole reaction part once more? I didn't get it, sir, because the communication is getting disrupted in the middle, sir.
Okay, sure, I will do it for you. So,
Okay, thank you,
when
sir.
we fabricate our cell, can you listen me, please?
Yes, sir, I can hear you now.
Okay, you can. Okay. So, when we fabricate our cells, the cathode constituents the lithium oxide. That is like which chemistry we are using. The lithium is present here in their oxide form, and the anode is the carbon derivative. That is a graphite form. So, what happens when we apply a external potential on the cell? The lithium oxide here, that is the here, can you see?
Yes, sir.
Okay,
Lithium,
the lithium is in its oxide form.
okay.
So reduction starts here when we apply a external potential, and this lithium ions goes to the, via electrolyte, goes to this graphite, that is the anode of the cell. And I think you might have read about the graphite and the graphene. They are the layered structure, that is, it is having a honeycomb lattice structure.
Yes, sir.
Yeah, so they are sheet-like they are sheet-like structure. Yeah, and this lithium ion gets trapped between this. The lithium ions get trapped here. This is what happens when external potential is applied. Then
Means between the between any two layers, the lithium ion is getting trapped.
yeah, between any two layers, if you will go to the nano level, that is the atomic level of the graphite, you will see the stacked layer-like structure.
Oh.
Hello, can you hear me?
Yes, sir.
So you will see the layer-like structure. This get trapped here, and the reduction occurs here. What happens when you put the load on the cell? Then again these lithium ions which are trapped here, they again go to the, this side of the cell, that is the from anode to the cathode, and the charge on the external side of the, they goes from the anode to the cathode again. I hope this is clear to you.
Yes, sir.
So I am moving ahead. Here are the some of the types of the lithium ion cells as per their chemistry. That is various parameters like the cost in production, like how much specific energy there will be, how much specific power the, if we are using a specific chemistry, how much specific power will be. how much the lifespan, that is, if we fabricate the cell, or how much of the charge in this charge cycle it can go, and and we operate how much the time one cycle of the charge goes, and the how much safely, that is, when we put load on it, does it get heated, and what the heating rate is. These are some of the parameters on which the chemistries are differentiated with. But in the current market scenario, hello,
Yes,
but
you are audible. Yeah, you can continue.
okay. So, but in current market scenario, these two chemistry, that is the NMC and the LFP are most common. These two chemistries. These two chemistries are more common. That is the NMC and the LFP. But NMC is having one disadvantage, that it get heated fast. It may be dangerous. There may be a thermal runaway in case of using the NMC chemistry. But there is advantage that it is having the higher specific power. It is having the higher charge rate. But when it comes to the LFP, it is the sorry, the NMC is having the faster charge rate. So uh, when it comes to the LFP, there is a longer life. There is a slower degradation of the or the consumption of the material inside, but it is having longer cycle. If we are going to charge a cell which is having the electric chemistry, it will having a larger charging time. So these are some of the advantages. But for the current time, for the time being, the researchers have come to the point where for various parameters there is a little bit difference between the NMC chemistry and the LFP chemistry. So still there is a research going on. In case of India, some of the companies are working on the NMC cells. In the recent Bangalore-based startup has successfully developed a battery pack which is having the NMC chemistry, but still it can be operated between the temperature like minus 40 degrees Celsius to the 65 degrees Celsius. In that case, even we can use it in a extreme weather of the in a extreme weather condition like of the Delhi, where the temperature almost goes to 48 or around 50. In that case, we can also use such cells, or we can use the battery packs. Moving ahead, so there are some of the parameters which are required to determine the performance of the cell, like open circuit voltage, like nominal voltage, like a state of a charge, like a C rate. These are some of the basic parameters which defines the performance of the cell. In case of the open circuit voltage, we can say that there is no application of any external potential on the circuit is. We can also say that the open circuit is the difference between the electrical potential between these two terminals of a device when they are completely disconnected from the any circuit. In case of the any device which is generating potential like a cell, like a solar cell, we can say that we have to apply such a potential on the electrodes or on the terminals, like we have to apply such a potential between these that the electron flowing through this get stopped. That is that there is a complete stoppage of the current flow. That is, we have to apply such a potential that there is no any flow of the current as well. Now coming to the nominal voltage, what the actually nominal voltage is. Let us suppose that we are having a cell and it is rated that its cylindrical cell, it is rated 3.7 volt. What happens when we apply the, for let us suppose that for the 0 to 1 second when we check the voltage, it's showing that there is a 4.2 volt, but for the next second it is showing that it is 3.5, and it is something like that. It is fluctuating between the some, for 3 to 5 seconds it is fluctuating between some voltage. Then it comes to the constant output, that is like it comes to the 3.7. This is the nominal voltage on which it stands up to for the longer time. This is the nominal voltage of a cell. The next thing is the state of charge. The state of charge is simple: how much the charge is left with the battery, how much of the capacity of the battery can be usable, and how much the is consumed, how much power, how much capacity of battery is consumed. Like someone is riding a bike, electric bike. After he goes to the almost 5 to 6 kilometer, and then the display mounted showing that he is left with only 80% of the battery. That is showing the state of the charge. That is, your battery is only 80% usable, and the 20% is used. 20% of the energy of the battery is consumed. This SOC has
Hello everyone, the webinar is going on Microsoft. Please join our Microsoft Teams. The link is given in chat box.
the state of the charge is something which is there any questions? Is there any query?
Sir, can you explain the nominal voltage once more?
Nominal voltage is like for which the, let us suppose that you are having a cell of Panasonic. Okay.
Yes.
And when definitely the, like sorry for using the word, let us suppose that it is rated with the nominal voltage of 3.7. when for the 0 second you connect you are checking the voltage with the multimeter. For the 0 second you find that the voltage is like 4 volt. For the next 1 second you are getting that the voltage is 4.3. Then again for the next second you are finding that the display on the multimeter is showing like 3.6, like 3.5. Then again it comes to the constant voltage where it is showing like 3. And for the longer time it remains the constant with a little bit fluctuations in between. This is called what a nominal voltage.
Means the stable, the stable value which it comes after.
Which is stable for the longer time.
Okay. Thank you, sir.
Okay. So the next thing is the C rate. That is the which defines the charge rate and the discharge rate of a battery. Like how much time a cell takes to go to the 100% of its capacity. How much time it takes to go to the completely 100%. This is the C rate of the battery. If a cell is rated like 1C, then it takes 1 hour in going to in 100% charging. If it is rated with like 0.5C, it takes around like 3 hours to go for the 100% charging. This is how the C rate is defined. But in case of the laboratory where the cells are being fabricated, these things are calculated using some formulas. So going ahead. This is how the cell pack is manufactured. Like first of all, they are graded. That is, the grading of cell is done first. Like we look for a cell with a similar maximum nominal capacity, similar nominal voltage, and of the similar chemistry also. These are the something which requires the similar chemistry is the one of the basic requirement for the designing of the pack, because if we are not going to select the similar chemistry, like we are aligning the NMC and the LFP cells. LFP cells is having a slower charging rate, while the NMC cells having the faster charging. When we go into the operation, there may situation come that it will start stabilizing the currents and the potential inside. Like cells are connected in series, there will be transfer of the charges from each cell to the another cell until where the capacities come to the equilibrium state. So that is why we need to choose a similar chemistry as well. So through a small demonstration, we can understand how actually a pack is made from the cell. That is a completely top-down approach. demonstration, we have seen that how a battery pack is made, is starting from the scratch, from fabricating the cells to the designing a battery pack using a automation system and using different CNC and PNC machines. And there is an advantage of going through the automations, like we will be having the scalable systems, precision systems, and precision, we can get a precision design as well. So moving ahead, the some of the things we require to achieve, to consider while designing a battery pack is like how much voltage is required. Like if installing, let us suppose that we are installing a motor of 1 kilowatt, which is having the capacity of that is rating of the 1 kilowatt and the 60 volt. So how much, which kind of battery pack we will going to design, or we will have to design, so it can provide power of the 1 kilowatt as well as the 60 volt. This the capacity requirement, the selections of the cells, like which chemistry, like we will be going for the LTO or the LCO or the NMC cells or the electric cells, based on their performance and based on our requirement, the type of application, like we are going for the cruising, like a vehicle for the cruising or for a simple commutation, or we are going for the heavy duty, or we are going for the industrial applications. The bus bar calculation, which will help in a proper flow of the current and help in lowering of the resistance. The safety standards, which is to be followed as per the local authority, which will define the various parameters to which we have to follow to design a battery pack, and to prevent the accident, to prevent the fire, and to prevent the various harms or the damages which can be lethal, or which can be due to the battery pack. These are the some of the requirements of the battery pack, that is its electrical design, its thermal design, the life, the durability, the battery management system, and the performance. When we talk about the electrical design, this is something like which kind of wiring harness we are including in our battery pack, which kind of material we will be using, which kind of the circuit we will be designing, the what would be the configuration of the cell. This is the one of the basic thing, like how much cell we have to connect in the series, how much cell we have to connect in the parallel as well. These are some of the basic electrical designing requirements. The thermal requirements, like so that maximum of the heat can dissipate to the environment, there is no accumulation of the, or there is no heat get trapped inside the battery pack. There may be the case of the thermal runaway, that is there will be heat generation, there will be more heat generation, there will be more and more heat generation due to the heat generation. Like if a single cell is heating and the cell makes the other cells to heat, due to this heating, there is more production of heat stars. This is the thermal runaway. So to prevent such things, it must be designed in a proper thermal design, so it prevents such of the accumulation of the heat inside the battery pack. When we consider the we have to choose such a chemistry, we have to choose such a robust design, we have to design it in such a way that it can sustain maximum vibration. We have to choose such a chemistry that it is having a longer life as well, and apart from that, the chemistry which we are using having a lower degradation rate with the time, with respect to the time. When we consider the durability, the pack material, the internal configurations of the pack, the internal structures of the pack, the outer shell of the pack, should be of such a material that it can sustain maximum vibration so that it can sustain the inertial force while on the braking, while on the acceleration. It is not something like that in the simple acceleration the battery pack get damaged or hurt or the damage some other components of the vehicle. So it should be of such material that it get easily attached with the vehicle and the material is lighter in the weight. The next thing is the battery management system. The battery management system, which is one of the basic thing of the battery pack, it completely controls the how much the power have to be delivered, how much power have to be delivered to the cells, how much current have to be delivered to the outer system or to the outer load, or how much the current we have to provide for the charging of the cells. This is the completely controlled by the battery management system. If our battery pack is equipped with the various sensors which are being controlled, which monitor the performance, like there is no change in the adequate temperature, like we have to keep the in case we have to keep the temperature from 25 to 30. These all are the functionaries of the battery management system. Next is the performance. The designing of such a battery pack, where it can perform with its maximum efficiency. Like if you are charging, it get charged in a shorter time. But when you put load on the cell or on the battery pack, it go for the longer duration, without any kind of heating, without any other fluctuations or without any interruption. These are some of the requirements of a battery pack. Some of the boundary conditions for the battery pack are like its electrical design, its thermal design, its mechanical design, the control system inside the battery which controls the current input and output and the various other factors as well. The electrical design ensures the how much the battery pack will be delivering the current outside the battery. That is, it also electrical design is also necessary to ensure the least resistance, maximum capacitance, maximum capacity that can follow to the controller or to the motor as well. We are all aware about the resistance dependence with the that is resistance is directly. Is there anything else? The resistance is directly proportional to the length, while it is inversely proportional to the area. That means if we choose the proper cross-sectional area of the material or the wiring harness we are using, or the bus bar we are implementing in it, we can have a better current flow through the circuits. We can have a lesser resistance. We will face the less resistance. These are, and apart from that, we have to use also material which is having a good conductance as well, where the flow of the electron, flow of the charge is continuous without any interruptions. These are some of the electrical design considerations. The thermal design consideration is how much temperature is better for the operation of the battery. Like what are the 25 degree to 30 degree Celsius, because when there is an increment in the temperature, there will be a change in the chemical activity, the chemical reaction inside the cells as well. There may be chances that the battery will start discharging fast. There may be chances that the ion inside the cells may get transported to other sites like from cathode to the anode, the rate may become faster. Then a situation comes when the temperature gets lower, like in case of the hilly areas, the ion's movement of the ion gets slower. This will definitely hamper the productive, that is the outcome or the performance of the cells. So such things have to be always keep in the check. A proper mechanical design to prevent the battery pack from the vibrations, to prevent the battery pack from the sudden impacts and the shocks as well. So such kind of so we have to design a robust mechanical structure as well. A control system to keep the various parameters of the battery pack in check by controlling and the monitoring its operation while it is on the load. While there is a load on the battery, right? It is in operation. Some of the noise factors for a battery pack, like the understanding the speed and the acceleration characteristic, is also important to ensure the battery pack that it is having a longer lifetime, that is goes for the last. That is, well, let us suppose that we have installed our battery pack in a vehicle. There may be case come that we suddenly accelerate the vehicle and from zero, let us suppose that from 0 to 2 seconds just we are trying to draw the maximum power from our battery. What happens in that case? There may be chances that there will be a failure inside the battery as well. There may be chances that the ions inside the battery will go for its for maximum transfer rate. This will lead to the overheating. This may lead to the other damages. This may lead to the faster decomposing of the material inside. So we have to keep check in of such of the characteristic like acceleration, that we have to how the acceleration is or how it will be working, depending on keeping in mind that we have to design such a battery pack also. To minimize the vibration, I have already discussed about that. To such a design is necessary that can increase sharp localization of stress and induce the failure points. The ambient management of the temperature as well, appropriate thermal management must be designed to keep the monitoring of the which keeps the monitoring of the temperature of the battery pack as well. While designing a battery pack, when we design a vehicle, when a producer or a company designs a vehicle, there are different kinds of load on the vehicle apart from the primary load, that is the motor and or the drive load. There may be the lighting system of the vehicle. There may be the air conditioners of the vehicle. So we have to also keep these things in consideration to design a proper battery pack which can provide the sufficient power to the auxiliary system as well as the primary system also. So development of the battery pack process, that is its thermal design, its mechanical design, its BMS design, its electrical design. So in case of the mechanical design, there must be a safe structure, like I already said that can sustain maximum vibration, can sustain the maximum inertial force in case of acceleration and deceleration. Must be if there is kind of any jerk, if the vehicle goes into the accident as well, it can sustain such kind of the incident of the force or the impact. While in such cases, a robust structure with ease of assembly and service, like if there is any damage inside the battery pack, if there is any cell which is not performing well or is completely decomposed, there must be such a design that we can easily replace those cells, we can easily service the battery pack we can easily remove the any component which is not in working, which is not performing well. So in such cases, we need to design such a structure which is having the ease of assembly, the aesthetic component and the lightweight. That is from the tip to toe, from fabricating the cells to designing a battery pack. There must be such a material use, like we have to choose such a we have to choose such a material which is having a lighter weight, or weight of the material should be lighter. So we have to choose such a material. There should be there should be such a material must be chosen which is which cost less and is much reliable as well. Electrical design is considered to check the capacity, voltage and current in the check. So there must be a proper capacity, there must be a good voltage, there may be the less resistance. A good isolation system is must be equipped with the cell as well, where the higher power is not get mingled or get tangled with the lower power. Like if there is a higher power supplied directly to the cell, it may burst, it may cause fire. So to prevent the short circuitage and the high voltage isolation, we have to design such a battery pack where it is configured properly. The bus bar we are selecting, the material we are selecting to connect the batteries, connect the cells in series and the parallel as well. That material should be of such a dimension, that material should be of such a chemistry that it provides proper passes for the electrons to deliver the good current or the good voltage as well, and provides a good help in providing a good capacity as well, and offers the lesser resistance. A good thermal design is also necessary to dissipate the heat accumulated inside the battery pack as well. A proper installment of the gas nozzles are required to make sure that while the cells are in, there is a chemical reaction inside the cell, the gas accumulated goes to the environment or goes to the outer of the battery pack as well. This may mitigate the thermal accidents. It will also help in increase the cell pack or the life. A good BMS design is necessary to ensure that the every cell which are connected in parallel or are connected in the series as well go into the they give proper amount of the charging current while battery is in charge, and proper amount of current or the capacity is drawn when the vehicle is on the load. Apart from that, to prevent any kind of failure, if there is a extra load on the on the battery design, other than the other than the rated capacity, the BMS should cut off the voltage supply to the main architecture of the vehicle, that is the main drive of the vehicle. And if there is a case where the cells are unable to supply the enough power, the battery should, in that case also, battery should cut off the supply. A better communication and diagnostic with the vehicle control system must also necessary, so it can provide a proper output from the cells, a proper load on the cells, the proper a proper SOC, a state of charge, which is being shown on the display in case of a vehicle. A good communication is necessary. In the current scenario, the Tesla and the Panasonic are in a joint venture. They are working on the WBMS, that is the wireless battery management system, where there will be a communication between the management system and the battery pack through a IoT algorithm, that is the Internet of Things, and there will be a data acquisition, and the BMS will control the battery pack accordingly as per the data accumulated. The the next thing is the C rate and the SOC calculation, that is the estimate of charge calculation. So this will be demonstrated through a example in the next slide, where we will calculate a battery pack, where we will design a battery pack as well. So some of the basic parameters I have chosen in case of the designing the battery pack. Like I am designing a battery pack for a two-wheeler, where I have decided to take the range as 200 kilometer. Let us suppose that we are taking the range equals to 200, and the speed we will be taking as the 50 kmph. Sorry for the we will be taking the speed as 50 kmph. Let us suppose that we have a motor which is rated as rated 1000 watt, that is 1 kilowatt, and the voltage for the operation of the consider as it voltage is the 60 volt. So from here we will calculate the how much current is required, that is the we will calculate the how much ampere hour is required by the vehicle if we are having a such configuration. There are the various parameters which are considered while designing a battery pack, like the motor power voltage, like a gross weight on the vehicle when it is on the operation, like the if the friction force it will be facing, like a drag force it will be facing. But for a simpler demonstration, we are considering here only the range, that is the here is the that is 200 kilometers. So from here we can interpret that we know that the motor capacity equals to the volt into the capacity, that is the which is required. So actually if we want the value in the kilowatt, then we have to consider 1000. We can also consider we have to consider it as a 1. So from here we can interpret that the H will be like we are having the motor power as 1, and the volt we have rated 60 volt. We have 1000 volt watt of the motor. So from here we have we can calculate that our AH, that is the capacity which will be required, will be 16.6 ampere. Now we are considering the range, and let us suppose that when we put the vehicle on the full acceleration, there is the 5% extra load on the battery. So we will add the capacity, that is the ampere hour, 5% more. That is we are considering this is completely experimental value, but for a simpler demonstration I am considering this value as the 5%. So the 16 into the 16.8 is 16.6. 5% is around the 17.5. The it is sorry, I need to change the pointer. It is around 7.5 17.5 approx. So from here we will calculate the power. That is power equals to V into I. So it is, we have the rating of the 60 volt. It will around like 1050 watt. So we got to know that the how much power will be required. Now the another thing starts from the here. We in our case we are considering the range. So we will calculate the travel factor. Travel factor is the distance the range divided by the speed. So here we get this value as we have the range of the 200 while the speed is 50 kmph. Here we get this value as we get this value as 4. So the power required will be that is the travel factor and the power we have calculated here, that is the 4. It will comes out to be 4200 watt. Now let us suppose that we are having a battery pack which is having the rating of the efficiency like 85 to 95%. So we consider the efficiency of the 85%. We can calculate the battery pack capacity. That is right now it is in the watt. We will change when we will change it into the kilowatt. It will be 4.2 kilowatt, and we will divide it with 0.85. That is 85% of the efficiency. We are going to the battery pack capacity requirement is 4.94 kilowatt. Now here we have learned that when we are going to design such a electric vehicle which will go up to the 200 km with the speed of the 50 km per hour, we have to design such a battery pack which provides a power of the 4.94 kilowatt. That means approx 5 kilowatt. We have to design such a battery pack. Now the next thing we will do is we will check that how much cell we have to put in the series, how much we have to put in the parallel as well. First of all, going to that, we will get to know that what the series and putting in the parallel. When the sorry, it is the negative. It is a negative when the anode is connected with the cathode. Again here anode is connected with the cathode. This is the series connection. But when anode is connected with the anode and the cathode is connected with the cathode, this is parallel connection. In case of the series connection, the voltage adds up. There is the addition of the voltage addition. While in case of the parallel, there is the capacity addition. So, to check that how much battery or how much cells we will require in parallel and series. In case of the series, the voltage, that is the 60, will be divided with the before that I need to mention one more thing, that let us suppose that we are having a cylindrical cell of the let us suppose that we are having a cylindrical cell having rating. The nominal voltage of 3.7 volt. In that case, we have to check that how much the cells will be connected in series. We have to divide the battery pack voltage. That is the, in our previous example, we learned that our battery pack voltage requirement is 60. That is when 60 volt will be supplied from battery pack to the motor will start run, and this will be divided with the nominal voltage of the, that is the V nominal voltage of the cell, that is 60 divided by 3.7. It will give around 20 cells. So 20 cells need to be aligned in the series. And for the parallel, let us suppose that our cell is rated with 1 is rated at 1 ampere per hour, that is its capacity is 1 ampere per hour. So, and in our case we got that we require a battery pack of 4.94 kilowatt, which can provide us this much of the power. So to check how much cells we have to connect in the parallel, we will divide the battery pack capacity with the nominal capacity of the cell design, that sorry, the cell which has been fabricated. So it turns out to be the 4, that is the 4 cells need to be connected in that is 4, not 4 cells, 4 strings need to be connected in the parallel. So apart from that, there one more thing is that how to connect. This is that on the basis of requirement we get to know that how we can connect the cells in parallel as well as the cells in series. So moving ahead, we will also look into the arrangement also, like if let us suppose that there are let us suppose that there are two kind of arrangement, that is the MP NS, and the second is the NS MP. Here m number of cells will be in parallel and the n number of modules in the series. When m number of cells make a parallel combination, then we require such a how much of the m we will require to connect in the series. These are the requirement. We will look into the advantages of the connections of this this arrangement also. And in case of the NSMP, the thing is that n number of cells in series, it will make a string, and how much such string need to be connected in parallel, that is the m number of. So what happens when we apply this arrangement? There is a addition of the capacity. This is here the capacity will be added, and the voltage will be added while the cells will be connected in series. And in this case, in the NSMP configuration, there will be voltage addition only. Capacity will only add after only after the strings are connected. And this is how the cells are designed and configured for the battery pack as well. So here are some of the case studies for the market, for the producers in market which are producing the electric vehicle. Like Hero is producing in the recent launch, it has brought a electric vehicle of a 250 watt to the market, which is having a motor of 250 watt, and charging time is 4 to 5 hours, and go up to the 85 kilometer in a single charge. While Okinawa is having a Sobi 1700 watt of motor, and the charging time is the 2 to 3 hours, while the range is 84 kilometers. Here and the Hero is having the same power of the motor, but the charging time of the ampere is the more, while the range of the ampere is also less. This is due to the cell chemistry. And the Ola has installed its vehicle with the 8500 watt of the motor power, and the charging time is of 6 hours and 30 minutes, and the range is of 181 kilometers. Above all, we can see that the Okinawa is having a better performance above the all. And so with all these learning of the battery pack designing, its advantage, its configuration, and its basic designing and designing as per the requirement and the configuring itself. We come to the end of this webinar. I thanks everyone for the part of this such beautiful moments, for such for being a part of this virtual seminar. Uh, so if there is any questions, now we can go ahead with.
Sir, can you please open the calculation?
Which one?
Second calculation.
Second slide.
Yeah, good evening. So
Yes,
we are
sir.
up for the question.
Hello. There is a. I am sorry to say that, but there is a background noise. So can you please work on that?
And I'm audible.
Yeah. Now you are audible.
Okay. So guys, we are up for the question answer session. So whatever your questions related to the battery pack, you can ask them one by one, and we will be
I think we must clear first the questions are available in the chat box, and we can go ahead with the question answers are here. I think Shiva and Nishant, we are okay with that. Yeah. So one by one we can take the questions in the chat box, and we can go ahead with the questions over here.
Okay.
So over to you, Shiva and Nishant.
Thank you, Shivam sir. Okay, so the first question that I see in the chat box is, what is active and passive balancing? Does it really necessary? Any ways to manage battery pack thermals? Okay, so for the questions like for active and passive balancing, so it is the whenever pack is bad, there are hundreds of cells which are connected in parallel combinations, right? And whenever the energy is drawn from a cell in a battery pack, so it is not compulsory that each and every cell will get equally discharged, right? Why does it happens? Because of maybe because of some manufacturing defect, or every cell is maybe similar in capacity or similar in design. There may be some this changes. There may be some difference in their charging and discharging of each and individual cell. So suppose that we have discharged the cell. The cell was having a rate capacity of 6 ampere and 3.5 volt, and 6 ampere battery cell was there, and we have discharged it for 10 minutes. Okay, let's say we have discharged it for 30 minutes. Okay, and after 30 minutes we will see the charge capacity which was earlier, which was 6000 mAh or 6 ampere. Now that capacity is reduced up to somewhere let's say 5.4 ampere, okay, or 5400 milliampere. So and if we compare it with another cell, with another similar cell, so there it may be possible that the different cell might have discharged up to 5.2 ampere. Okay, why does this happen? That generally that completely depends upon the rate, that completely depend upon the each and every individual cell can be charged and discharged separately. So when this variation happens, that completely impact upon the overall life cycle of the battery pack. So to equally charge and discharge these cells, that have these conditions are possible in both ways, right? So if to equally charge and discharge the cell, we need balancing of the cell. All right. So first of all, we understood what generally happens. What generally happens for this during the charging discharging of the cell, and now what is balancing? We will understand. Okay. So balancing means that we are equalizing the capacity of all the cell inside the battery pack. I hope you are getting this, guys. Yes, no, maybe.
Yes, sir.
Yes.
Okay.
Yes, sir.
So whenever we are balancing these cells, so there are two methods for balancing it. One is the active balancing and one is passive balancing. So first of all, let's understand what is passive balancing. So in case of passive balancing, let's understand that, let's suppose that there are 5 cells connected in series and making a small battery pack. And when we are discharging it, suppose my 2 of the cell got discharged up to, let's say, 40%. Okay, they got discharged 40% and 3 cells got discharged only 20% or let's say 30% only. So there is a difference between the difference of 10% between other cells. Okay. So in case of passive balancing, what it will do, it will discharge like the BMS. BMS is basically responsible all these functions, how to like balance the cell. Okay. So in this case, what will this passive balancing will do? It will simply the cells which was 30% discharged, the BMS will like dissipate the extra charge stored in them. So it will take all the remaining 10% or discharge 10% charge from the all the 3 cells and dissipate it out of the battery pack. In the we can say it is a kind of loss. Okay, but in case of active balancing, what it will do, it will simply redistribute the BMS will redistribute the extra energy inside the cells only. Okay, in one case what we are doing, we are extracting the extra energy and removing it from the battery pack. Okay, in the form of heat or whatever you can say. Okay, and in active balancing, what we are doing, we are redistributing it on the among the other cells. Is that clear? Does it make sense?
Yes, sir.
Okay. So does it really necessary? Yes, it is definitely necessary. Why? Because suppose that in our battery packs you have purchased a bike. So we are talking about real scenario now. What generally happens when people are not taking care of their battery packs? Okay. Suppose that you have purchased a new electric vehicle. Okay, and when you were charged, when your battery was fully charged, it was showing 100% charge. But after running for, and range was about 80 km. But after going 60 km, it shows that battery is like completely discharged. So in that case, what is generally happening over there? Maybe one of the cell or one of the spring inside the battery pack is completely discharged. Not the overall battery pack is completely discharged. So even if the one of the cell is completely discharged, so in that case, the whole of the battery pack will be will come into the rest state, and you will not be able to extract the energy from the battery pack. So that's why this balancing is necessary. Okay, and in case of passive balancing and active balancing, if we are using some cheap BMS, so they are using this passive balancing. If you are using some good BMS, so they are using the active balancing. That completely depends upon the kind of BMS you are using. Okay. Any ways to battery pack thermals? Yes, definitely. There are multiple methods to manage the battery pack thermals. So thermal is conditioned. So the first question is clear. Am I going too fast? So, the question is clear. Sorry, the answer is clear.
Yes, sir.
Okay, let's move on to the next question. Any way to manage the battery pack thermals? Yes, definitely. There are multiple ways to control the battery pack thermals. One is one we can simply say the forced cooling. That is by installing the fans inside the battery pack. So that you have generally seen that we are using the normal air fans for removing the extra heat. And another method is using the we can say liquid cooling methods, or some paste cooling method are also used in some of the battery packs. So what is the difference? So if we talk about normal fan cooling method, so they are that you can generally see in middle range or middle range battery pack. That means from 8 to 10 kilowatt of battery pack, you will see this air cool fans or this forced cooling or air fans are used, like heat from the battery pack. But if we talk about in case of heavy battery packs, or which are used for for light commercial vehicles and the heavy commercial vehicles, so definitely we have to use there this liquid cooling method. Okay. Okay. Next question: does high C rating will decrease the lifespan of a cell? Yes. C from the battery pack. So if you are abstracting the high amount of charge from the battery pack, let's say again taking the same example of the same battery or same cell, that is a cell is of 3.5 volt nominal voltage and 6000 mAh capacity or 6 ampere capacity. So the C rating means that if you are discharging 6 ampere of the current from the battery pack, then from that cell, then the complete cell will get discharged within 1 hour. That is C rating. Okay. Now, if you are discharging it with the higher C rating, that let's say you are discharging it with a 2C, 3C or 5C. Okay. In that case, what is happening? If you are discharging it with 2C, okay, that means twice the current. Earlier you are discharging with 6 ampere. Now you are discharging with 12 ampere. So what will happen? Your discharge time will reduce. That means within 30 minutes, earlier you were discharging in 60 minutes. Now within 30 minutes, within 30 minutes your cell will get completely discharged. Okay. Now if you will discharge the same cell with 5C, then what will happen? 5 into 6, that means 30 ampere you are 30 ampere of a current you are abstracting from that cell, right? That means again 60 divided by 5 will give you the 60 divided by, that means 12 minutes. Okay, within 12 minutes, if you are discharging with 5C, your battery will be completely, we can say, discharged. Okay, so that is C rating. Now, coming to the question, does high C rating will decrease the lifespan of a cell? Yes, definitely. Why? Because of the internal chemical reactions or the internal changes happening inside the cell. What happens inside the cell when we are discharging with the high capacity or high current, that we can say the internal resistance or the electrons or the transfer of the electrons will be at high speed when you are extracting the current with the high rating. So that means your electrons will be moving with the high speed, which will again generate the heat inside the cell. Okay, one thing is the heat will be generated, and also another thing is the resistance will be generated. Okay, once the heat is generated inside the cell, what it will do? It will simply change the structure of the cell, like the salt which is used at the anode and the cathode. So there, the size of the cell or the size of the these particles inside the cell will get changed or will get increased. Okay, once the size of that particle is increased, that means the surface area of the electrode or cathode material inside the cell is decreased. Oh, sorry, this particle is increased and the surface area will get decreased. So surface area inside the cell decreasing means overall limit of battery, overall capacity of cell to store the charge will get decreased. So this I can explain with the help of the engine. We all have seen the engine head. Yes, no? Right. So there we are using the pins to increase the surface area of the engine head so that we can cool it easily, right? So same thing is happening inside the cell whenever if the surface area of the anode and cathode material will get decreased, that means that it will reduce the energy storage capacity of the cell. That's why if you will see it in the long run, then your charge storage capacity of the cell will get decreased, and ultimately it will result in the shorter lifespan. Same thing will happen with the fast charging also, if you are charging it with the high C rating. Okay, so this is for your awareness that whenever you are purchasing the electric vehicle, if you are charging frequently, if you are charging your battery frequently at fast chargers, as fast charging, so in that case you will see that this your lifespan of the battery will get decreased. Clear?
Yes, sir.
Okay, let's move on to the next question. Apart from the cell chemistry, do we consider anything for the battery design? Cell chemistry, yes, you have to consider the overall power rating, like how much power your battery, like whenever you are designing it for a particular vehicle, definitely you will design it for a for a particular vehicle. Your what is the overall load of your vehicle, okay, and what is the maximum speed you want from that vehicle, how much uh, what is the power of the motor that you want for your vehicle, and what is the maximum voltage or minimum voltage of the cell, all right. And there are like these are the many other factors that you have to consider while selecting the battery pack design. Okay, again the cooling temperature, cooling methodologies you have to select. Okay, if whether you need any extra kind of cooling or not, or the region for which you are designing the battery pack. Suppose if you have to design the battery pack for let's say take an example for the Rajasthan, right, where the temperature goes, normal temperature goes up to the 50 in summer. Okay, so there you have to design the battery pack differently. You have to consider that okay, your operating temperature must be within the 20 to like operating temperature of the cell must be within 20 to 70 degrees Celsius or 60 degrees Celsius for the cell or for the battery pack. So there you have to design it differently. And so if the same battery pack you have to design for the Kashmir or let's say for Ladakh region where the temperature goes sometimes goes below minus. So in that case you have to design the battery pack differently. Okay. Next question.
So, like when we buy a car in Rajasthan, like can't we drive that car in Kashmir?
Definitely. See, that completely depends upon the way that car was the battery pack of that car is manufactured. In generally, you had seen that like a country like India, it is having vast this difference in its temperature region. So that's why we all have already seen this problem with the burning of the electric vehicles. So if I go back into the March and April season, so we all have heard about this that the electric vehicles are catching the fire, right? So why does that happening? Why it was happening? Because people were charging the electric vehicles. Like some people, we have seen that in the video also, they were charging the electric vehicles in the afternoon time, and where the temperature of the atmosphere is already very high, and some people sometimes we have seen that they are charging in the night, but it may be because of the fault, or maybe because of some manufacturing default or failure in the BMS that the vehicle got fired. But especially in case of India, we have seen that there's a huge range or huge difference in the temperature regions of temperature diversity inside India. So in that case, what will happen? You will definitely able to drive your vehicle in that region, but you will see that the life of your battery pack is somewhere will get affected in long run.
Okay.
Because see the temperature range is between operating temperature range for the cell is between the best it will perform between the 20 degrees Celsius and 40 to 50 degrees Celsius. All right, if you are driving the vehicle in any other condition other than this, then that will definitely affect the life of the battery pack.
Okay.
Yeah. So it is not like that you will not be able to drive it there. Definitely you will be drive it there, but if you are able to drive your vehicle in Rajasthan for 5 hours, so there you might be able to drive it for 3.5 hour only. That also is.
Yeah. The minimum operating temperature is 20 degrees Celsius, or it will be like because in hill station it will be like 1 or 2 degrees, right? So I considered that when I raised this question and I got the answer. Thanks.
Again, that is also dependent on some different types of chemistry. Also, some chemistry, some cell chemistry may got that up to like 70 to 60 degrees Celsius temperature, and below temperature is 10 degrees Celsius. That depends on that also.
Yes. Thanks.
Hello, sir. This is Subir from MIT.
Yeah.
I have one question. I'm building a EV. So in there, I wanted to go with two battery packs. So first battery pack is of, let's say, 20 Ah capacity, and the second battery pack is of 10 Ah capacity. So by using Anderson cables, just I'm putting them parallel after BMS, because I have a separate BMS in separate battery packs. So I'm just making them parallel and I'm supplying to my motor, let's say. So in that case, is that preferred? Because I don't know how it behaves after one battery discharges. Can you talk on this?
Yeah, definitely. So see, whenever you are connecting your different battery packs in series or in parallel, right? That means you are limiting your capacities of the cell or battery pack, right? So let us take this example. You have two cells, one cell with the 6 ampere, one cell with the 4 ampere, and you have connected them in let's say in parallel, right? So what will happen? You have the different capacities of the cell, right? So in that case, when discharging both the cells like equally, right? When you are discharging both the cells simultaneously, what will happen? Both cells are working as a single battery pack. Okay, that means again, I have told you that I have already given you this example with the SOC, right? That means one SOC is 100% and another SOC is 80%. Okay, so in that case, what will happen when your 10 Ah battery pack will be completely discharged? After that, your battery pack or your BMS will cut off the battery pack, cut off the power from the battery pack. You will get the signal that you have drained the complete energy from the battery. Okay, so in that case, if you want that your 20 Ah battery pack to like work for a longer time period, so in that case you can use that you can do the switching of the battery packs. Okay, just like you are swiping the battery, so you can do the switching of the battery pack over there.
But sir, as I'm using them parallel, let's say 10 Ah will discharge and it will be cut off, it will be out of the system indirectly. And that 20 Ah have another 10 Ah capacity, maybe that can stretch up, right?
That will be still remain there, but for that to use that, what you have to cut off that extra 10 Ah battery from the completely discharged 10 Ah battery pack from your vehicle.
Why, sir? Because I have a BMS. I have a separate BMS actually. For 10 Ah I have a separate, and for 28 I have a separate. So does current go in? Because I don't think it will go in BMS from one cell to other.
So for that you will need a third BMS. Okay. So for that case you will need a third BMS that will simultaneously look into both the battery packs and discharge both of them equally. Okay. Each individual's battery pack is having their own BMS, right? And if you are connecting it with the external BMS or with the third BMS, your BMS is continuously discharging the battery pack, right?
Yes.
And once the 10 Ah is discharged completely, and the 20 Ah is still remaining. So what in that case happens? That one of their circuit is getting open there. First of all, I try to understand this thing. You are connecting in parallel. Okay, one battery completely discharged, your circuit will get open. Getting this?
No, sir. I thought the upper battery is complete discharge. I feel like it's dummy. It's not giving any output now. So anyhow, my system is connected to lower battery.
For that case, you can still use that battery pack, but in that case you have to disconnect the first one, because it's still or you have to do the we can say the bridging of the battery packs. That means one you will unless and until what is happening in this parallel connection, one is completely discharged. Okay, you simply understand Your upper one is 20%, lower one is 10%. After some time, what happened? The 10 Ah from both the battery packs are drained, right?
Yes.
And
Is
it's
that?
still, but it's still the 10 Ah capacity is stored in the first one, remaining in the first battery, right?
Yes.
So, but your circuit, the way you are connecting it with the battery or connecting with the motor or controller, what is happening there? You have connected two batteries into the parallel connection. That means one is completely discharged and one is still having some charge. In that case, what is happening? Your circuit is getting open. Getting this, you are simply
If they are in series, the circuit will get open. But as they are in parallel, both the plus is connected to motor. Let's say motor plus, both the plus are connected, minus are connected to motor current primary. So in that case, circuit is not opening. As 10 A is remaining, it is connected to motor directly, right?
okay. I got that. Yeah, I got that. So in that case, overall battery pack. Yeah, in that case, your speed will be limited, but still you will be able to use the battery pack.
So I can prefer that, right? So if I am using 3C batteries and I am discharging at 2C, so at the start I will discharge with 1C, 1C each, and after first battery dies, I can discharge 2C from the second battery, right?
In that case, your overall speed might get reduced because you are connecting the different battery packs. Yeah. And in that case, your overall see what happening here in that case that you will be able to discharge it with up to 20C.
Okay.
Up to 20 ampere was there. So up to you can get a one at a single time you can get up to 20 ampere in the first case, but once the 10 Ah battery pack is discharged, after that what is happening? You are having only 10 ampere current, 10 Ah current. So in that case, overall top speed or maximum speed will be limited.
Okay, if the second battery C rating, like if the both battery C rating is very high and my consumption is literally like 1C or 2C, let's say for I have a 3C battery, but I am consuming with 1C, so I think speed will also be maintained, right?
Yeah, that is a different. That is completely different. If we were talking about completely charged, like whether we will be able to use or not. So once that 10 is the battery pack is the remaining only 10. So whatever the speed you are going here, you will not be able to achieve that. And if you are draining the battery pack with different C, that is completely different thing. Okay.
So that speed doesn't depend on C rating, is it?
It can definitely speed depend upon C rating.
Okay.
In yearly case, you are getting 10 ampere from two different cell batteries.
Yes, sir.
But after that, what were happening? You were having only 10 ampere.
Yes.
Okay, so if your battery need extra power, so you will that is your maximum limit is now 10 ampere only.
Yes, yes. If I am playing under that, I will say.
Yeah.
Yeah. Thank you. Thank you.
Sir, sir. Hello. Yes, sir. What I'm asking that those who don't have any doubt, can they leave the chat?
We are about to end the session.
Okay, sir. One more last question: that when will these students get the certificate?
Shivam sir will be able to answer that. We will get it.
You will get the
By today
email after this webinar, and you will, like there will be the steps to get the certificate. We will mention the steps over there. You will get the email after the completion of this webinar. Okay.
No. What I'm asking that those who don't have doubts right now, shall
Yeah,
they
you
leave the
can.
chat?
Yeah, you can.
Okay.
So we have the last question in the chat box. Will EVs are eco-friendly than normal fuel-based vehicles on PS06? Can explain, sir. Okay. Well, to answer this, if we compare both like eco-friendly vehicles, like normal electric vehicles and the BS6 vehicle, so definitely if we are directly burning the fuel, BS6 vehicles we are having less carbon content no doubt. But still, if we are using electric vehicles, they are much more eco-friendly only when we are generating or whatever the energy sources, uh, like power generating sources we are using, they are if we
Hello, Shivam, are we done with the question and answers? Hello, Shivam, are you there? Hello,
Yes, sir.
Shivam, are you there? So Nishant, you can take up the questions. Then.
Yes, sir. So going ahead with the question, please.
Sir, I have a question, sir.
Yeah.
am I audible?
Yes, sir.
You are.
Okay. So, okay.
Hello.
So I was answering the last question on eco-friendly, like electric vehicle and BS6. Right. Electric vehicles are only eco-friendly if the power source, like what the power source we are generating, the way we are generating the power. That means if we are getting the power from the thermal power stations, then definitely electric vehicles are not safe. Okay, and if we are generating the power from let's say regenerative energy like solar, wind, or some other like eco-friendly power generation method, then definitely electric vehicles are much more this safer than or safer for the environment. And BS06 definitely they have reduced in BS06 the carbon content is reduced, but still they there will be some disadvantages to the environment, and even the extraction of the like petroleum or petroleum from the fossil fuels is still uh, very like costly, and we can say that very like dangerous for the environment. EVs are actually generating more carbon print. EVs are actually generating more carbon print. That is only the way that I have already explained. In that, how can we mitigate voltage imbalance between the strings? So that will be done with that is handled by the PMS only. Okay, there are some algorithms which are used for this meant to this control the balancing between the cells or into the string. So that is completely looked after by the this BMS and its algorithm and the kind of algorithm which is used in the circuit. Okay, I hope we have answered all the questions.
Sir, one more question, sir.
Yeah.
Sir, a battery pack in e-vehicle and mobile phones are they similar, sir? Because they are all made of lithium-ion batteries.
Yeah, both the if we talk about both like lithium-ion cells in the used in the electric vehicles and the one used in the mobiles, they both are similar. Okay, only difference is that of the capacity. Okay.
Sir, I can't hear you, sir. Can you repeat?
Am I audible?
Yes, sir.
Yes, you are. Yes, you are.
Okay. Yeah, both the lithium-ion cells are similar. Only difference is with the capacity or with the lithium-ion cell of the mobile is made, and the shape of the lithium, like shape of the cells that are used into this mobile packs. Only difference is with the capacity. All right, and if you see the voltage, then voltage is also, you will find the cell voltage is also somewhere around 3.4 voltage, 3.6 voltage, 3.8 voltage, and the capacity may vary. Okay, in case of more this cells used or batteries used inside the mobile is around 4000 mAh, or now we are seeing up to 5000 mAh, or maybe somewhere up to 6000 mAh batteries we are seeing in the mobiles, right? And the only like one is the capacity and another is the shape factor or the form factor are different. That's they are similar. And even even the mobile phones are also using BMS.
Yes, sir.
Okay. So, so shall we end the session?
Sir, last question, sir.
Yeah.
Sir, what is strings which is connected in parallel, sir? Series connection of connected with cells, and what is strings?
Strings connected in parallel means, suppose that okay, whenever we are making the battery packs, so when two cells are connected in series, so that means we are increasing the voltage, right? And whenever we are connecting the cells into the parallel, we are increasing the ampere. Okay, so suppose that we have a two cell of 1.5 volt and 1 ampere. So if we will connect them in series, that means we are making it 3 volt and 1 ampere. Right, but when the same cells we are connecting in parallel, so in that case what will happen, our voltage will remain same, that 1.5, but the capacity will increase, that from 1 ampere it will now increase to the 2 ampere. Okay, so whenever we are making the battery packs, so let's take an example that we are making a battery pack of 12 volt and 10 ampere. Okay, 12 volt and 10 ampere we are making the battery pack. So in 12 volt, let's say the cells which are used is 4 ampere cell, 4 volt and 1 ampere cells are used. So in that case, when we are connecting 4 volt cells in series, so we will get 12 volt and 1 ampere. Getting this?
Yes, sir. Yes, sir.
Now we have got this is one string, 4 volt 3 cell in 1 ampere, which is where we are connected 3 cell with 4 volt and 1 ampere. The output is 12 volt and 1 ampere. All right. Now what we want the battery pack of 12